All right, y'all. So today we're going to be doing the SN1 and SN2 reactions. So just like all the other times, the first thing I want to bring to your attention is the things to be worried about in terms of hazardous materials. So let me flip this guy around. And so for this lab, we're going to be using 1-butanol, calcium chloride, anhydrous, hydrobromic acid, and sulfuric acid, sodium hydrogen carbonate. And so for your product, the 1-bromobutane, that is flammable and is also an irritant. 1-butanol is flammable and also an irritant. And hydrobromic acid is toxic and corrosive, and sulfuric acid is toxic and an oxidizer. Um, and here's just a little a tidbit about that in terms of how it causes burns and things like that. So again, that's why we wear our gloves and keep our hair up and typically wear like a lab coat of some sort. Um, we don't really use flames in our labs, but if you did, knowing that this is something that is flammable would be something to note. Also, sometimes just being too hot can induce what's called flames. So something else to consider. Also, don't ingest it. Don't breathe it in too deeply or eat it. Um, so yeah. So we're going to go through the video first and record all of our data. Does anyone have any questions before we get started with that?
There's no data sheet for this lab, right?
There is no data sheet. Well, let's see what he wants us for you guys to record. And I think it's more for the post lab stuff. So here you're gonna weigh 1 gram of butanol. Yeah, it says record weight on post lab sheet. So there is no data sheet per se, but it's for the post lab sheet. So you're gonna add 2 mils of hydrobromic acid and 1 mil of sulfuric acid. Did you guys all see that? 1.448 for 1 bromobutane. Okay. So do we know how to calculate theoretical and percent yield?
You're supposed to find the grams per mole and then how many grams you use versus like the how many moles. And then I know that's part of it.
Okay, so you're right in that we have to use our grams and our moles, right? So what was our initial weight of the 1 butanol that we used?
2 grams.
We used 2 grams?
No, I thought it was 1 gram.
I thought it was 1.
Well, what was it in the video? Did he actually have down?
It was 1 gram in the video.
It was exactly 1 gram? Like exactly 1 gram?
I could be wrong, but that's what I wrote down.
Okay, let's go back.
I saw 1.07.
1.07. Okay, so okay, here he is adding the 1 butanol, right? So yeah, 1.07, right? And so we have to convert this to moles, right? So is there a value that we're given that will allow us to convert it to moles? And basically what we're trying to do here is we're also trying to determine what our limiting reagent is between the 1 butanol and the hydrobromic acid. So there is a value that we are given. So butanol grams per mole is I have written down here. And you want the grams to cancel out, right? So you have 1 mole. So you multiply your starting weight times the moles per gram of that. So it's 74.1 grams per mole. 1 grams. And then you then multiply that by the ratio of how much butanol makes how much bromobutane, sorry. And that's a 1-to-1 ratio. And so with 1.07, so you do 1.07 divided by 74.1, and you get 0.0144. And that's how many moles of 1 bromobutane that you make from 1 gram of 1 butanol.
I'm sorry, can you repeat that?
Which part? The whole thing?
Just like what the end was.
So the end is 0.0144 moles of 1 bromobutane. That's how much you end up having. And then, so we're using 2 mils of the hydrobromic acid. And so 1 mil is equal to 1 gram. So we're starting out with 2 grams of hydrobromic acid. And just like the 1 butanol, you do 1 mole of hydrobromic acid over its weight, which is 80.9. So grams per mole, but you write the mole on top and the grams on the bottom. And so you get 80.9 grams, and then you do the same thing. You do for 1 mole of hydrobromic acid, you make 1 mole of 1 bromobutane. And so instead of doing 1, how much did he have for the hydrobromic acid? Was there a specific weight for that? Or did he just add it to the total volume?
Just added, I thought.
Yeah, I think it just adds it to the tube. So then you could just say 2 grams then for that. So yeah, so then you should get a value equal to 0.0247 moles of 1 bromobutane. And so between those two, which one is the limiting reactant?
No.
Right, because it's the one that gets used up first, right? Because it makes less. And so what was our actual yield? What was the final yield that he made?
It was 1.447 grams.
So 1.447 grams. Okay. And so then okay, so we have that value. So before that though, you take that 0.0134 moles and you multiply it by the a molecular weight of 1 bromobutane, which is 137 grams per mole. And so you multiply 0.0134 by 137 grams per mole. So you'll cancel out the moles, right? And so you get 0.0134 times 137, and you get 1.835. So you get about 1.84 grams. And so you have, that's your theoretical yield. That's how much you would have if this reaction were to go to completion. So then you take your, in order to get percent yield, that is equal to your actual yield, right, over your theoretical yield. And we know both of these values, so we have, you said 1.447 over 1.84. And then you multiply that by 100, and then you get your percent yield. So 1.447 divided by times 100, you get a 78.82% recovery. And so that's pretty much what this lab is about. Do we understand the Sn1 and Sn2 reactions for the most part? Did he go over that with you guys in the lecture? Yeah. Let's see. Just trying to think. Do you guys know what the difference is between an Sn2 and an Sn1 reaction? So just that the Sn1 reaction happens, it's not a concerted reaction, if that's the right word to use. It happens like stepwise. The leaving group goes, and then the nucleophile then attacks, as opposed to an Sn2 mechanism. Like it shows right here, the nucleophile does a backside attack, and the leaving group leaves, and that happens just in one step. So yeah, a concerted would be the right word to use there. I'm trying to think what else you guys need to know. Yeah, I mean, if you guys don't have any questions, that's pretty much the whole lab. It's actually a lot faster one than last week. I figured they'd all be about 30-minute long videos at this point, but that one was super fast. So does anyone else have any other questions? Anything about any of the other assignments? Or I know that some of you have emailed about the late assignments that he let you guys do, have them turned in by Wednesday. And after this point, so after this last Wednesday, anything now submitted late will get 10% taken off. It's either 10% or 10 points. I can't remember, but I think it's just 10%. So yeah, no other questions, nothing. All right, y'all. Well, this is a pretty easy lab. So just be ready for next week. We are going to be doing, what are we doing next week? We're doing qualitative tests for the hydroxyl group in organic compounds. So be ready for that one. All right.
But just one question. So the experiment we just did was the Sn2 reaction?
Yep.
Right. So looking at the post lab, it has questions about performing an Sn1 experiment. Should we just make up what we would expect to see?
Yep.
Okay.
Correct. Yeah, if you go through this, oh, here, hold on a second real quick, guys. Let me share my screen again. So yeah, so what we did today was the synthesizing 1-bromobutane using the microscale techniques, and then it gives the procedure, blah, blah, blah. And then it has through macro scale techniques. And then it has factors affecting Sn1 reactions, which we didn't do. So we didn't use 2-bromo, 2-methylpropane, or any of those things like that. So anyway, yeah, just write down what you'd expect to see. And that's pretty much it, all right? Cool. All right, well, take care.
Thank you.
Have a
Have
good
a nice
weekend. You too. Bye.